Now that you have run about LD and LW assembly instruction in RISC-V architecture, and let's perform the disassembly instruction using 332 program in simulator mode. So what you're looking at is 332 program, and it's about to run LD assembly instruction and LW assembly instruction. Before running this assembly instruction, I'm going to wrap up the syntax of LD assembly instruction or LW assembly instruction in this example program. So here, I'm going to run this assembly instruction, that is LD assembly instruction. So when you run LD and LW assembly instruction, it will perform the load operation from the memory. So I can say that if you run this assembly instruction, it will load the data from the memory space. So main difference between LD and LW assembly instruction is the size of data to load. So in case of LD assembly instruction, it will load the data up to 8 bytes. In case of LW assembly instruction, it will load the data up to 4 bytes. That is only difference between LD assembly instruction and LW assembly instruction. And this assembly instruction has the same feature, that is to load the data from the memory space. Now that I have introduced LD and LW assembly instruction, and I'm going to show you what is going to happen after running this assembly instruction. So whenever you look into the LD assembly instruction, and the first thing you have to check is the base register in LD assembly instruction. So in case of this assembly instruction, the base register is X19 register, and the value in X19 register should be added to the offset. So in case of this assembly instruction, the offset is 0x10. So this calculation is should be performed, should access the memory spaces to load the data. So in this case, what we have to observe and check is the value in X19 register. So in the 332 program, the X19 register has this value. So I'm going to copy the value in this register into the notepad. So please take a look at this. The value in X19 register has this value. If you add this offset that is specified in the LD assembly instruction to this address specified in X19 register, the result is going to be this address. So if you interpret this assembly instruction, so you have to say that, oh, when you run this assembly instruction, the memory content at this address will be loaded into the X15 register, because X15 registers is going to be the destination register for this assembly instruction. So now that you have understand the syntax of this assembly instruction, let's figure out the value in this memory location. So for this, you need to use this command. That command is input in 332 command line. It will allow us to view the data at specific memory spaces. So now it's about to run this assembly instruction. So I'm going to choose the start button to run this assembly instruction. And please pay attention to the value in the X15 register, because X15 register is destination register for this operation. So please take a look at the value in the X15 register. X15 register is updated to this value because at this memory spaces, and this value is located at this memory spaces, and that is the main reason to why the value in X15 register is updated accordingly. So please keep in mind that, so as for LD assembly instruction read the whole 8-byte in this memory location, but as for LW assembly instruction, it only load 5-byte size of the data into the destination register. So here I'm going to run the second assembly instruction, that is LW assembly instruction. So I'm going to explain in more detail on this assembly instruction before running this one. And here, if we compare this assembly instruction with the first assembly instruction, so first thing we have to notice is that it has the same base address, that is X19 register, and then offset is the same. Offset for the second assembly instruction is JRX10, and the main difference between two assembly instruction is the destination register. In case of second assembly instruction, the destination registers is X16 register. So what is going to happen if we run this assembly instruction? Let's take a look at this, what is going to happen after I click the start button to run this assembly instruction. Let me hit. So please take a look at this. As observed in this window box, the value in X16 registers is updated to this value because LW assembly instruction is to load the data from the memory spaces up to the 4-byte. But in case of LD assembly instruction, it will load the data from the memory area up to 8-byte. That is key difference between LD and LW assembly instruction. So now that I perform the two assembly instruction which support load operation, so I'm going to revert to what I did by using undo assembly instruction. And no, l.undo is command supported by trace32 command, not assembly instruction. So I'm going to run this one command. So I run this command again. Please take a look at this. It will move back to the original state where I start to run this assembly instruction. So I'm going to run this assembly instruction, and please pay attention to the value in X15 register. Please take a look at this. 8-byte of X15 register is updated, and please take a look at this. In case of LW assembly instruction, and only 4-byte inside X15 register is updated. Remember that those two assembly instruction has access to the same memory location because it has same base register and same offset, but the result is different. So in this tutorial video, I perform the simulation to run by running the LD and LW assembly instruction. The next video I'm going to run another assembly instruction, that is SW and LS, SW and SD assembly instruction, which support store operation.